Hello everyone, welcome back to our NDT training session. I am Mutalakshmi Kanagaraj and I am excited to continue our journey into the world of non-destructive testing. Today we are going to focus on a specific and widely used NDT method, magnetic testing, with a special emphasis on magnetic particle testing. As a quality expert holding ASNT Level 3 certification in 10 methods and ISO 9712 Level 3 in UT PUT TOEFL, I bring a comprehensive and practical approach to understanding this subject. In this session, we will go slide by slide, breaking down the principles, techniques, and applications of magnetic particle testing. My goal is to ensure that everyone, including our beginner level learners, can easily grasp the core concept. So let's begin by understanding what magnetic testing is and why magnetic particle testing is such a crucial inspection method in the NDT field. Let's start our session. We will start right at the beginning. What is magnetic testing or MT? Well, it's very important member of the electromagnetic non-destructive testing family. This means we are dealing with magnetic fields and electricity to find defects without causing any damage to the part itself. One of the biggest draws is that it offers fast and economical way to assess the integrity of ferromagnetic materials. In MT, we are using only ferromagnetic materials. So, if you are working with materials that can be magnetized, MT is often a fantastic choice. Now, within magnetic testing, we frequently talk about magnetic particle testing. It's crucial to understand that magnetic particle testing is actually a type of flux leakage testing. However, it's so distinct and widely used that it's treated as a separate method within NDT. Because it specifically uses magnetic particles to form a visible indications of flaws. Just to clarify, when we talk about flux leakage testing, generally it typically excludes test using magnetic particles. So while the principle of flux leakage is at its heart, the use of particles gives MPT its unique identity. So we move the next slide. Industrial uses of magnetic testing. Magnetic testing is widely used in various industries because it can quickly and effectively detect surface and near surface flaws in ferromagnetic material such as carbon steel and low alloy steel, these kind of steels. Industries apply magnetic testing at different stages of a component's life cycle, mainly three categories. One is production testing, the next one is receiving testing, next one is in-service testing. In production testing, they check the quality of material before they leave the manufacturing plant. Where it is done, the steel mills and factories producing billets, rods, bars, tubes, wire ropes and similar products. So why this is so much important means it identifies the cracks, seams, laps and any other discontinuities in raw or semi-finished products. It ensures the final product integrity before dispatch. Example, a steel producer uses a magnetic particle testing on oil-filled tubular goods to make sure there are no surface defects before shipping. Next, receiving testing. Receiving testing is to verify incoming materials before they are used in fabrication or construction. Who performs it? Any idea? Okay. End users or third party inspectors or perform this receiving test. Why this is so much important means it confirms the supplier meets technical specification, the required technical specifications, codes or standards. It prevents defective materials from entering production lines. Example, a refinery receiving tubular goods, that oil filled tubular goods, will perform MT on them to ensure they are free of cracks before welding into pipelines. Next, we'll see in-service testing. In-service testing means to inspect components during service or after use to ensure continued safety and reliability. Where these in-service testings are used? Only wire ropes, installed tubing, retrieved oil-filled tubular goods and other steel structures. It detects cracks, fatigue damage and wear before a failure occurs. It helps in failure prediction and maintenance planning. Example, offshore platforms use MT to inspect the wire ropes and lifting equipments regularly to avoid the accidents. Let's move on the next slide. 4 steps in magnetic testing. Magnetic testing is based on the principle that flaws in a ferromagnetic material disturb the magnetic field. When the disturbance happens, magnetic flux leaks out, and in magnetic particle testing, the leakage attracts the magnetic particles, creating a visible indication. Magnetic testing can be broken down into the 4 main steps. First one, magnetize the test object. The first and most important step is to induce a magnetic field in the component. This can be done using direct current technique or alternating current technique or yokes, prods, coils or central conductors. Any of the technique used, any cracks, voids or inclusions will disturb the magnetic field, causing flux leakage at the flaw location. Second step is scan with the detector or magnetic particles. Once magnetized, the surface is inspected for flux leakage. In magnetic particle testing, instead of electronic detectors, we use magnetic particles, dry powder or wet suspension. Dry powder for rough surface or outdoor work, wet suspension for high sensitivity. So here we are using one dry powder and another one is wet suspension. So the magnetic particles migrate and cluster at leakage points, forming a visible indication of flaws. Third step is process the output or indications. After scanning, indications must be enhanced or made clear for evaluation. under white light for visible particles or UV light for fluorescent particles in dark condition that are mentioned in the standard. Proper processing ensures that real defects are visible while minimizing false indication. So, fourth step is present the result for interpretation. The final step is to evaluate and document the findings. Record size, location and orientation of discontinuities. It compares indication with acceptance criteria from codes or standards. Its clear presentation ensures that engineers can make decision about repair, replacement or continued use of part. It's based on acceptance criteria. It will be accepted or rejected. And next topic is magnetic particle testing principles. MPT is based on the magnetic flux leakage principle. Discontinuity distorts the magnetic field and flux leaks out at the flaw. Magnetic particles are attracted to the leakage. A visible pattern forms along the discontinuities, that is indication forms. Particles can be dry or wet suspension, colored or fluorescent, and it reveals cracks, laps, seams or porosities, forming a visible patterns of flaws. This simple process makes magnetic particle testing fast, visible and reliable for detecting surface and near surface flaws in steel. Let's move on the next topic. Purpose and advantages of magnetic particle testing. It is one of the most widely used NDT methods for detecting surface and near surface discontinuities in ferromagnetic materials. The purpose and advantages of this method make it a key inspection tool in various industries. It's highly effective at identifying cracks, seams, laps and porosities at the surface or just below the surface. Defect flaws early in the process, preventing waste. Detecting these issues early helps prevent defective materials from moving to the next stage of protection or service. Next is applicable at multiple stages. MPT can be applied at any stage of component's life cycle, like raw material inspection or intermediate processes. That means during machining, heat treating or welding. Then final in-service inspection also MPT available on operating components like wire ropes or tubings. From metal protection to final finishing, it can be used. Can detect delayed cracking in welds. MPT can detect hydrogen induced cracking or stress relief cracks that appear after a time delay. For example, welds can be rechecked after cooling to catch delayed defects. So this is the best example. For time gap between weld and final test. And the main advantage of MPT is it's high sensitive to surface defects. MPT can detect very fine cracks that are invisible to the naked eye, even under normal lighting also. And quick and cost effective, Flexible application can be applied to large or small components also in the workshop or field. And both dry and wet particle methods can be used depending on the surface condition. Direct visible indication. The magnetic particles form a visible indication directly over the flaw, and this makes interpretation easier and faster compared to some other NDT methods. The basic MPT procedure is: first step is magnetize the object. It's to create a magnetic field. Then apply a magnetic particles. It's dry or wet, and observe the interpret indications under the right lighting, white lighting or UV lighting. It's based on the standard. Let's move the next topic: capabilities and limitations. Every NDT method has strength and weaknesses, and understanding both is important for choosing the right inspection method. So MPT is very effective for detecting surface cracks, but it has some limitations that restrict its use. First, we see the capabilities of MPT. Detection of surface cracks reveals the surface cracks and very tight flaws invisible to the eye. MPT is highly sensitive to surface breaking defects, including cracks, laps, seams, even hairline cracks that are invisible to the naked eye can be detected in the MPT. Same time, detection of near surface flaws and can also detect shallow subsurface flaws depending on magnetic field strength, size, depth and shape of the flaws. For example, small subsurface inclusion or lack of fusion in wells may be indicated. Immediate visual result indications are formed directly over the flaw, giving a real-time inspection result. If we are using fluorescent particles under UV light, further enhance visibility in low light conditions as per the standard. Then limitations of MPT. Only works on ferromagnetic material. MPT cannot be used on non-magnetic materials like aluminum, copper, plastics. Works only on ferromagnetic materials like carbon steel, ferritic steel and some cast irons. Magnetic field orientation is critical because the cracks are best detected when the magnetic field is perpendicular to the flaw. If this is a material, this is a magnetic field direction, but crack is perpendicular to the magnetic field, often requires multi-directional magnetization to ensure complete coverage. Require very high current. Large or thick components require very high magnetizing current, which may need special equipment. Then demagnetization must be required. After testing, residual magnetism can attract debris or interfere with the component's function. Demagnetization is often required before the part is returned to the service. On understanding these capabilities and limitations, it helps ensure the right NDT method is chosen for each inspection task. I will share some questions related to this topic. Please write your answers in the comment box so we can review and discuss them together. I hope this detailed explanation gives you a clearer and more comprehensive understanding of magnetic testing and magnetic particle testing based on the provided sources. Let me know if you have any further questions. Write in the comment box. Thank you.